Hi everyone. In this video, I'm going to go over Monday's work from the week 14 packet. So for the do now, I'm asking, what does it mean for energy to be conserved in a collision? You can pause the video and write down your answer. So conserved means stay the same in this context. In other words, the total amount of kinetic energy before the collision would be the same as the total amount after the collision. So a collision is between two objects, so that means if you calculated the kinetic energy of each object and added them together before the collision, and then if you did the same thing after the collision, you would get the same total number. And I'm also reminding you that the test this Thursday is still happening. It's going to be a test on energy and work and power. So for today's activity, you need to click on the link in Google Classroom. It's the same one from Friday. Click on Intro right here. Change elasticity to 0, so just slide this all the way to inelastic. And check the box here that says More Data. So it's really similar to what we did on Friday. You'll be copying down the initial momentum numbers right before you press play in the simulation. And then you'll press play, and then you'll get the final momentum numbers. So these are the numbers we're looking at. Momentum, and remember the units are kilograms times meters per second, so when you copy down the numbers, also copy down the units. So these are the numbers I would put for my initial momentum. I'll press play and stop it immediately after they collide. And these are the new numbers for my final momentum. You can see that something different between this collision and Friday's collision is that the objects stick together. And they move a lot more slowly. So after you copy the numbers from the simulation into your table here and here, your job is to see if the momentum was actually conserved, meaning did it stay the same before and after the collision. So for question 1, you're adding up the initial momentum of each object, that's these two numbers. Question 2, you're adding up the final momentum of each object, that's these two numbers. Question 3, just did the total momentum stay the same? Was question 1 and question 2, did they have the same number? 4 and 5, I'm asking you to calculate the kinetic energy of object 1 before the collision. For that, you're going to be using those two numbers, the mass, 0.5 kilograms, and the velocity, 1.0 meters per second. So for question 4, you'll be using the formula KE equals 1/2 mv squared. Same for question 5, same formula, but now we'll be using these two numbers. The one for mass 2, or object 2, and velocity 2, negative 0.5 meters per second. Keep in mind that both of these numbers should be positive, because once you square a negative number, it becomes positive. So if you did get a negative answer, put it in your calculator again, and make sure you have a parentheses around your number like that. Question 6. What is the total amount of kinetic energy present before the collision? You'll be adding up 4 and 5 together to get your answer to question 6. Question 7, we're just doing the same thing, but now it's after the collision. Question 8, same thing, but after the collision. And then you'll add these two numbers up to get your answer here.